This video is on scientific notation, and this is just one part of your video. So I would have paper out, notes out. I believe this is target 11, so plan to write a lot and plan to think a lot. Here we go. So first of all, scientific notation, it's just a way to write numbers as the product of a decimal and then a power of 10. So sometimes we have really large numbers and we don't want to write them all out, so we use scientific notation. So again, a way to write numbers as the product, because we're multiplying, of a decimal and powers of 10. Okay, so when we multiply by powers of 10, the exponent right here is what helps us to decide where to place the decimal in our big number. So right now, this probably is review for all of you. Since my decimal is a 3, I just know I am multiplying really by 10 to the third power, which is the same as 1,000. So I'm really multiplying that number by 1,000, so I know my number will be larger because I'm multiplying by 1,000. So we've known the trick is you just move the decimal over whatever the exponent is, 3 places. So I'm going to come over to my number and do that. I'm going to start where the decimal is, and I'm going to go, oops, I'm not going to do that. Hold on. Doot, doot. Okay, back to this. The decimal's right there. I'm just going to count 1, 2, 3. And I know my decimal's now going to be behind the 4. So I'm going to rewrite my number, 1, 1, 6, 3, 4. And you obviously don't need to put a decimal there. It's like saying, write the number 19. We don't write 19 with a decimal here. So when you end with this number, again, you don't need that decimal there. But you do need some commas. So I know that that would be 11,634. So that would be my answer to this scientific notation problem. I'm making the number larger. Okay, so try this problem right here. We have 11.634 times 10 to the 0 power. So, first thing I do is I see, what does this equal? 10 to the 0 power, if you remember from before, is equal to 1. This one's fairly easy now, because when I multiply 1 by any number, it's that number. The other thing you can think about is my exponent is 0. That is how many places I want to move my decimal. So in this case, I want to move my decimal 0 places. So my final answer here is just exactly the original. Okay, now write this next one down on your paper. This one's a little bit different. What's different about this is we have a negative exponent. So how does scientific notation work when you have a negative exponent? Well, just think again, 10 to the negative first is really the same as 1 over 10 to the first, which is the same as 1 over 10. And when you multiply something by a fraction, you're getting a part of this whole number. So you really only want a part of this. If you want a part of something, it's going to be smaller than the original number. So right now, what I think every time is when I have a negative exponent and I'm doing scientific notation, it's like instead of multiplying by a power of 10, I'm dividing by a power of 10. So in my mind, I'm thinking my answer needs to be smaller than what this is. And that helps me know which way to move the decimal. So if I was multiplying by 10, I know I'd move the decimal to the right. But I'm not multiplying by 10, I can think of it as dividing by 10. And my exponent is a 1, so I know I need to move the decimal 1. And in this case, I'm not multiplying, so I'm dividing, so I know I have to move it to the left. So moving it 1 to the left, my final answer is 1.1634. And again, I ask myself, is this smaller than the original? And then I know I'm checking my answer. So that's what you should get for that one. Okay, so these two problems, I want you to pause the video and try them yourself, and then unpause it and check to see how I did it. If you don't think you can do it by yourself at all, then just keep watching and I will explain. Okay, so first one, I know that my exponent is 2, so that's really the same as 100, 10 to the second power. So if I'm multiplying my number by 100, I know I'm making my number bigger. And because it's exponent of 2, I move it 2 places to the right. So my final answer, 1623, I know my decimal goes there, 0.4. Final answer. Somebody once asked me, in scientific notation, do we always do powers of 10? Have we ever done like a decimal times 5 to the second power? And the answer is no. We never do that. We always use powers of 10 because our decimal system is based on powers of 10. When you think of it, it's tenths, hundredths, thousandths, or tens, hundreds, that way. So yeah, our scientific notation is always base 10. Okay, so come down here and check this one. So now it's a negative exponent, so you should be thinking, hey, I'm going to actually be making the number smaller, because what I'm really doing is dividing by 10 to the second power. I'm really dividing it by 100. So I need to move my number to the left if I'm making the number smaller. So 1, 2. So my final answer, let's see, I'm going to put a 0 here just to make it easier. 1, 6, 2, 3, 4. Love dealing with all these big numbers. Fantastic. All right, so hopefully you did okay. I'm going to see if I can find some more problems to give you here. All right, here are 3 problems. You need to write each product in standard form, which means you basically use scientific notation to solve it. So pause the video, try it by yourself, and then check in to see how you did. All right, so number 1. I have 10 to the 5th power. I know I'm going to make my number larger because 10 to the 5th power is 1, 2, 3, 4, 5. It's like multiplying that number by 100,000. That's a lot. Easy part to do this. My exponent's 5, so I'm going to move it 5 places, and I know I'm making it bigger, so I'm moving it to the right. I need to rewrite it so I have some room here. So I'm going to go 1, 2, 3, 4, 5. Zip. And in all these fantastic little dips, we need to add zeros. Please don't just leave your answer like that with all those little curly things. It's really obnoxious to read. So you want to write it the correct way. So we have a 2, a 7, then there's 1, 2, 3, 4 zeros. 1, 2, 3, 4. Add your commas, and there's your final answer. Hopefully you did fantastic. Okay, number 2. Woohoo! Negative exponents. I'm going to make the number smaller because it's really like doing this. 1, 2, 3, 4. It's like finding 10,000ths of this number. So I'm going to make it really small. I'm dividing by 10,000. So my exponent's 4, so I'm going to move it 4 places, in this case to the left, because I need to make it smaller. So 1, 2, 3, 4. Kind of running into space over here. Add my zeros. Final answer, let's see. I'm going to add another 0 here just to be fun. 0, 0, 2, and a 5. Final answer. Down here, I put a tricky one here to stump you. Hopefully I didn't, but let's see what happens. Here's how I think about this problem. Right now, I know this is the tenths, hundredths, thousandths, 10,000ths. So in my mind, I think 10,000ths. Okay, so I could also write this like this. 1/10,000th. And so I'm kind of making you think backwards here. What would this look like if I had to write it with exponents? Well, I know it's going to be a negative exponent. So in my mind, right away, I'm knowing I need to make this number smaller over here. So 1, 2, 3, 4. There's 4 zeros down here, so I know my exponent needs to be 4. So 10 to the negative 4th. Makes it really easy then for me to know I need to move my decimal 4 places, and in this case to the right. And I'm going to make some more room for myself. 1, 2, 3, 4. Add in your zeros, and then rewrite it. Point. 1, 2, 3. There's 3 zeros. There's my decimal. 1, 2, 3, and oh no, I'm going to run out of room. 4 and a smushed 5. Alright, there's your answer for that one. So see how you did. If you still need help, you know how much I love questions, so bring them tomorrow. Toodles.